Good afternoon, everyone. Well, if you're watching this video, it's because I'm not in class today. I had some meetings this afternoon, so you are left to watch the notes and take them on your own. So I am going to go through these and see how you guys do. Before we get started, you should have already done the quizzes. I am taking that for a grade, so go back and make sure that you do the quizzes that you were supposed to do for the warm-up. And then you should get the notes from the sub. The sub should have passed these out already. And you will watch this video and take the notes along with the video. And when you're finished, show the sub that you have completed the notes and they will give you your assignment. So the first thing that we're going to do is multiply radicals. So today we're going to be multiplying radicals. I can multiply radicals. So by the end of this class, you are going to be able to multiply radicals. We have already learned how to add and subtract radicals and to simplify radicals. So we are going to apply everything that we know to today's lesson. Remember, to add and subtract radicals, they must be like radicals. They have to look exactly the same. However, today we're going to multiply radicals and they do not have to be like radicals. They do not have to be like radicals. Any two or more radicals can be multiplied together. It doesn't matter what they look like. They can still be multiplied together. But we can only multiply the coefficients by coefficients and radicals multiply by radicals. You can't mix them up, okay? So then we're going to simplify when necessary, or look for the parentheses. Oh, not simplify, multiply. Sorry. Multiply when necessary. Look for the parentheses. Remember, parentheses means multiply. And always make sure your final answer is fully simplified. All right, so we're going to simplify the expression. I did post a couple of videos at the bottom of Canvas. If you are struggling with any of this information, you can also go and watch those videos. They are other people doing the same thing that I'm doing here. However, they might explain it a little bit differently, so that might be helpful to you if what I say today is not working out for you. Okay, so check those out if you can, if you're struggling with some stuff. All right, so we're going to multiply. We have two radicals here we're going to multiply together. We have radical 6 times radical 8. So we are going to multiply them together. And if you notice, when we multiply them together, we're going to get radical 48. Well, to get radical 48, we have to simplify this again anyway, okay? So which means we're going to have to basically undo the multiplication by writing down what the factors are and simplifying each factor. Okay, I'm going to circle my pairs, my friends, my pairs of friends. I got two 2's there. I'm going to circle 2 cross 1. I also have a pair of 2's here, circle 2, cross 1. Since I have 2 circled, I have to multiply them back together. 2 times 2 gives me 4. And I'm left with my lonely 3. So radical 3 goes back in the radical. So the answer for that would be 4 radical 3. You could break it down and do radical 6, break that down into 2 and 3, and break down radical 8 into 4 and 2. Before you multiply them together, you could break them down into smaller parts and then put them all back together. It's up to you. You're going to put it back together anyway, so it's easier just to put it together and then simplify it. And the good thing is you already have the factors because you just multiplied them together. So it works out a little easier. All right, number 2. Radical 10 times radical 2, since they're both radicals, we can multiply them together and we get radical 20. We can break it down. And again, just because 10 times 2 gave me 20, I don't have to break 20 down into 10 and 2. I can break it down into 4 and 5 since 4 is a perfect square. I know that 4 is going to turn into 2 2's and it's going to come out of the radical. So my answer would be 2 radical 5. You could still use 10 and 2, but it's easier whenever you find perfect squares that you can just simplify quicker. So 2 radical 5 is your answer for number 2. All right, number 3, we have a mixture of radicals and numbers. So remember, it is assumed that there's a 1 in front of the radical 5, even though we don't see it. And we're only going to multiply the numbers with numbers, which means the coefficients with coefficients. So 1 times 3 is 3. And then we're going to multiply the radical with the radical. So radical 5 times radical 3 is radical 15. 15, can it break down to 5 and 3? There's nothing else. These are both prime numbers, so I can't really do anything else with it. So my final answer would be 3 radical 15. Number 4. We still have some numbers here. We're going to multiply the numbers together. We get 2 times 5, which is 10. And then we have radical 5 and radical 8. We're going to multiply together, which is radical 40. Then we're going to take 40 and we're going to simplify it. Again, you could use 8 and 5, and I'm going to use 4 and 10. And I know 4 is a perfect square, so that breaks down into 2 and 2. 10 breaks down into 5 and 2, but 5 and 2 are prime numbers, so I have to multiply those back together and put it back into the radical. So I have this 2. What happens to it? I bring it up. I multiply it to the 10. So I'm going to have 20 with radical 10. So all of the rules that we've been doing so far are applying here. We just have to make sure that we do apply them and make sure that it's in simplest form. All right, now we got some extra parentheses here. So we are going to take what's outside of the parentheses just like we normally would for distributive property. We're going to distribute the square root of 6 to the square root of 10, and we also have to distribute the square root of 6 to the square root of 2. So the square root of 6 times square root of 10 is radical 60. Minus square root of 6 times square root of 2 is square root of 12, or radical 12. Now we have the 2 of them that we can subtract. So we've already learned adding and subtracting. Remember, they have to be like terms to add or subtract. So let's see if we can find anything that we can simplify to make these like terms. 60. We can break that down into, if you can find a perfect square. If you don't, you can go with the most common one that you probably would pick out first, which would be 10 and 6. 10 breaks down into 2 and 5. 6 is 2 and 3. Circle our doubles, cross 1. So the square root of 60 is 2 with radical 15. Square root of 12 breaks down into 4 and 3. 4 is a perfect square, so that's going to go 2 and 2. And this is going to be 2 with radical 3. Since they're both in simplified form, we cannot subtract them because they are not like radicals. So we have to keep that as our answer. All right, I want you to try number 6 and see what you can get with number 6. So take a minute to try that on your own. You may want to pause the video while you are working just to give you some time to work on it. All right, you're going to distribute the 10 to the square root of 10 to everything inside the parentheses. So the square root of 10 times square root of 5 is square root of 50 plus square root of 100. And if you notice, if we have the square root of 10 and the square root of 10, they're both 10s multiplied together. The square root of 100 is going to come out as just 10. So I know that this breaks down into 10 and 10, or just 10. Square root of 50, we can break it down into 25 and 2, and we get 5 and 5. So we're going to have 5 radical 2 plus 10. We can't put them together because 10 is a whole number, and 5 goes with the radical 2. They're not like terms, so our final answer will be left just like this, 5 radical 2 plus 10. All right. Number 7 is also very similar, but now we're going to have a number in front. So we have a coefficient in front of the 7, it's radical 7. We have to distribute this to everything inside the parentheses. And remember, only the numbers get multiplied to the numbers, the radicals get multiplied to the radicals. So 3 times 2 is 6. Radical 7 times radical 2 is radical 14. Plus 3 times 1 is 3. And then radical 6 times radical 7 is radical 42. If we look at these, we could break down 14 to 7 and 2, but 7 and 2 are both prime numbers, so none of them can come out. So that one stays as 6 square root of 14. 42 breaks down into 6 and 7. 6 goes to 2 and 3, but none of them are doubles, so this again is going to stay as plus 3 radical 42. So your answer is 6 radical 14 plus 3 radical 42. All right, maybe pause it and see if you can try number 8. I'm going to write the answer in here, so when you are done, you can check it to make sure that you are on the right track. All right, number 9. Now we have lots of more stuff going on. We have 2 binomials multiplied together. So this is just like your FOIL. You are going to FOIL, which means you are going to multiply the first terms together. So 4 times radical 10 plus your outside terms is going to be negative 2 times negative radical 2 times radical 10 is minus radical 20. Inside terms is plus 4 radical 6, and then radical 6 times radical 2 is minus radical 12. See if there's anything that we can simplify out of all of those radicals, and or any if we can put together that are like radicals. So radical 10 is already in simplest form because 5 and 2 are both prime numbers, so I can't do anything with 4 radical 10. It's going to stay the same. Radical 20 can get broken down into 4 and 5. 4 is a perfect square, so 2 and 2. So this is going to be minus 2 radical 5. 6 is in simplest form already because 2 times 3 are both prime numbers. So I can't do anything with 4 radical 6. And then 12 is 4 radical 3. So this breaks down into 2 and 2. So this is going to be minus 2 square root of 3. There are no like radicals, so I cannot do anything else with this. This is my final answer. All right, I want you to pause it and see if you can do number 10. I'm going to write in the answer to number 10. I want you to see if you can get that answer. All right, check your answer with number 10 when you are ready and see if you get that answer. If you are not practicing these on your own, you're going to have a really tough time whenever it comes time to take the quiz. Okay, so you want to make sure that you're practicing and you know how to simplify all of these. All right, number 11. What do I know about this 2 right here? What does it tell me to do? Yes, you got it. It tells me to write it 2 times. So we're going to write the binomial 2 times and multiply it together. Just like we did above, we're going to use FOIL. So when we do, we get 5 times 5, which is 25. 5 times radical 3. The inside is plus 5 times radical 3. And my last terms is plus radical 3 times radical 3 is radical 9. I still have 25 plus 5 plus 5. I can add these 2 together because they're the same radical, radical 3. So I'm going to add the 5 together, but I'm going to keep the radical 3, so plus 10 radical 3. And then radical 9, we know breaks down into 3 and 3, so the answer to that is plus 3. Combine my like terms, which are my whole numbers, or my integers. I get 25 plus 3 is 28 plus 10 radical 3. And that is your final answer. All right, I want you to try number 12. So try number 12. Remember, you need to write that radical or that binomial twice and then FOIL it. So pause the video, take a minute to try it on your own. I'm going to write in the answer for you so that you can check and see if you're on the right track. All right, I wrote in the answer, so check and see, did you get what I got? And if you did, you know you're doing well. All right, at the bottom, I want you to go ahead and fill in that self-evaluation. How are you doing with multiplying radicals? Are you understanding it? What can you use more help with? Last class we did simplifying, adding, and subtracting radicals. Where are you with that? Are you a 1, 2, 3, or 4? Which did you find easier, add, subtract, or multiply radicals, and why? So there you have it. There's the notes for today. You have the rest of the class period to work on your homework. Please take this up to the sub. Show them that you have completed your assignment or that you've completed the notes, and they will give you the assignment for today. All right, well, I hope you have a fantastic day, and happy Valentine's Day to you all, and I will see you next class period.